Welcome to the deep dive. You've handed us, well, quite an impressive stack of sources this time. It really stretches far beyond simple articles.
Yeah, we're looking at technical papers, user experience reports, industry forecasts. Quite a mix.
Right. And our job, as always, is to take this, well, volume of information and really distill it, boil it down into synthesized knowledge that gives you a genuine professional edge.
Mm-hmm.
For the last few years, the main conversation around AI, it's been almost entirely focused on language models, hasn't it?
Absolutely. Text in, text out. That's been the dominant paradigm.
Exactly. We feed it text, we get text back. But human understanding.
Well, and therefore, any truly advanced professional workflow, it's multisensory. We don't just read documents.
We look at charts, we listen to presentations, we analyze visual evidence. It's all integrated.
So the core mission of this deep dive is really to move past those limitations, past text-only AI, and explore the true frontier, integrated intelligence.
Yeah, getting into how these systems handle everything at once. We're tackling a question that I think defines the immediate future of knowledge work. What happens when your AI can process that full, sometimes chaotic, spectrum of human communication?
Not just the words.
Not just the words, but the charts, your voice, your code, your video footage,
Mm-hmm.
and crucially, all at once.
Mm-hmm.
This shift, right,
Mm-hmm.
from single-sense input to this integrated, holistic understanding,
Mm-hmm.
that's the power we're about to unpack.
That's exactly the right context to set. Our goal today, it's really threefold, and it's focused entirely on practical, actionable understanding for you.
Okay.
First, we need to precisely define multimodal AI, and maybe touch on the underlying mechanism that allows it to truly combine these different data types, not just stitch them together.
Right, what makes it actually work differently?
Second, we'll showcase some high-impact, specific examples of its application across these senses, vision, audio, video, code, and we'll identify the leading platforms driving this change. And third, most critically, we'll analyze the immense, immediate professional benefits these capabilities create. Because that's the real payoff here.
Absolutely.
We're moving beyond those single-purpose AI tools, the ones that handle data streams separately. We're moving to integrated intelligence systems.
Yeah.
And understanding this transition and, frankly, mastering these new workflows, well, that's your essential shortcut. It's the way to be really well-informed on this next phase of AI mastery.
Okay, let's unpack this then. Let's anchor ourselves with the fundamental definition. It's right there in your source material. We hear multimodal, and intuitively, yeah, we think many types.
Right.
But what does multimodal AI actually mean when we talk about its function, its structure?
Yeah, the definition sounds simple on the surface, but technically it's revolutionary. Multimodal AI is defined as AI that processes text, image, audio, video, and code together. And that final word together, that's where the paradigm shift really lives. That's the core idea.
So not just handling them one after another or side by side.
Exactly. Historically, think about it. If you wanted to analyze, say, a financial document, you'd maybe use one AI tool to transcribe the CEO's comments from an audio recording.
Okay.
Then a separate model, probably, for generating the text summary of the written report.
Right.
And maybe another older computer vision model to try and interpret the stock chart.
Siloed.
Totally siloed. These tools just didn't talk to each other effectively. They each spoke their own language, text tokens, pixel arrays, audio waves, different worlds.
So when we talk about moving past text-only models,
Yeah.
we're not just saying, oh, look, they added a camera input now. It's deeper than that.
Much deeper.
We're saying the foundational architecture, the very way the model is built, has changed. It can natively accept, analyze, and synthesize these varied data norms.
Yes, without needing these sort of clumsy intermediary translation steps between formats.
Okay, can we peek under the hood a little bit
Yeah.
without getting too bogged down in the jargon for our listener? How does it actually do that, combine these different languages?
Right. The key concept, and this is simplified, of course, lies in what's called the shared embedding space.
Shared embedding space. Okay.
Basically, every piece of information, whether it's a word from the text, a pixel in an image, a tiny slice of an audio waveform, it gets converted into a common numerical language, a vector representation.
So everything becomes numbers
Mm-hmm.
in the same kind of mathematical space.
Exactly. And this vector representation allows the AI to understand the semantics of the image, the meaning of the sound, the context of the text, all mapped onto the same conceptual landscape.
Oh, okay. So it's not just seeing pixels, it's seeing the idea of the image represented numerically next to the idea of the text.
Precisely. So when you upload that chart we mentioned and maybe some text describing a market trend alongside it, the AI doesn't see two separate files in isolation.
Right.
It sees two sets of vectors, two sets of meanings existing in the same semantic space. And because they're in the same space, it's much easier for the AI to spot correlations or contradictions or connections between them.
That makes sense.
That synthesized processing, understanding the relationships between the different types of data, that's what allows the AI to effectively think about the whole problem, not just the individual pieces.
That makes the shift really clear. It's moving from, like you said, isolated translation tools to genuine integrated comprehension.
But okay, this raises a critical question for the professional user, doesn't it?
What's that?
If I feed it a highly specialized input, say a really niche industrial schematic, something it might not have seen much of in training, or a chart using some kind of proprietary visualization method my company uses.
Right. How reliable is it then?
Yeah. Can we trust its synthesis in those edge cases? Are we still fundamentally bound by the quality and breadth of its training data on that specific niche? Or does this integrated processing truly allow it to extrapolate new meaning more reliably?
That is a crucial point, and it definitely speaks to the real-world limitations. We shouldn't overstate it. The AI's ability to synthesize is still fundamentally dependent on its foundational training data. That hasn't changed.
However, the multimodal advantage here is that it gains context from the other modalities. So let's take your example. If the AI is somewhat unfamiliar with the exact niche schematic visual input,
Yeah.
but you also provide an extremely detailed textual report, maybe the engineer's notes, explaining that schematics function and components in plain language.
Okay, so I give it text alongside the image.
Right. The AI can then cross-reference. It uses its likely very robust understanding built on its vast text training to help guide its interpretation of the less familiar visual features.
It uses the text to understand the picture better.
Exactly. It's leveraging its strength in one modality, text, to compensate for a potential weakness in another, niche visuals. This leads to a much more reliable result than a vision-only model could ever provide in that situation.
So it's triangulating meaning across the senses.
That's a great way to put it, triangulating meaning. That ability radically improves reliability, especially in specialized professional fields where you often have that mix of standard text and very specific visuals or data formats.
So the transition isn't just about efficiency, though we'll get to that. It's also about potentially greater accuracy through this triangulation.
Yes, definitely.
Okay, so if we use that analogy from the source material, it's the difference between just sending someone a set of written notes versus, giving them a full-blown presentation where you can point at the slide, gesture, play a sound clip.
Exactly.
The increase in that contextual bandwidth, all the different ways you're communicating, it radically reduces the chance of misinterpretation.
Absolutely. And the ultimate goal here, as the sources really emphasize, is to mimic how a human colleague works.
Right.
A person doesn't look at a dense engineering report in isolation,
No.
then separately read the QA notes, then separately listen to the audio interview with the lead engineer.
You do it all together, switching back and forth.
You process all those inputs simultaneously, or nearly simultaneously, to arrive at a holistic understanding. Multimodal AI is finally starting to close that gap. It can now tackle complex documents, complex situations that rely heavily on context embedded across all those different formats. What's really fascinating here, I think, is moving past the definition, the theory, and detailing exactly how this integrated intelligence actually manifests, how it works across different data types, demonstrating the specific outputs that can enhance professional analysis for you.
Okay, let's start with vision and data. This seems immediately applicable to almost anyone dealing with metrics, reports, data visualizations. It's everywhere.
It really is.
So when a professional uploads a complex chart, maybe a multi-line graph or a scatter plot with lots of variables, what is the multimodal system delivering that goes beyond just, reading the axis labels?
Much more. When the input is a chart, the output is dynamic pattern finding and potentially data manipulation. It's far more than just descriptive labeling.
Okay, dynamic pattern finding. What does that mean in practice?
Specifically, the sources highlight its ability to identify complex relationships within the visual data. For example, the AI can spot covariance between variables that might be represented on different axes or even across different charts if you provide several.
So it sees how two things plotted differently are moving together or inversely.
Precisely. Or another example, it might recognize when a visual outlier, say a big spike in a trend line, doesn't seem to align with the textual forecast provided in the accompanying executive summary you also uploaded.
It flags inconsistencies between the picture and the words describing the picture.
Exactly. That's the cross-modal understanding at work. This effectively turns a static image, a chart, into a dynamic, queryable data source.
Queryable, so I can ask it questions about the chart.
Yes. If you upload an image of, say, a complex sales funnel chart, you could immediately ask the AI something like, based on the conversion rates visible in this image, draft a bulleted list of the 3 highest friction points shown in the Q4 data. The AI synthesizes the visual data structure, the funnel stages, the drop-off rates, and transforms it directly into a textual, actionable analysis, the bullet points you asked for.
That is a massive analytical accelerator. I mean, it completely bypasses that tedious step of manually transcribing the data points from the chart or just eyeballing it before you can even start asking intelligent questions about the data it represents.
Right, you jump straight to analysis.
Okay, what about standard images? Things like photos, diagrams, maybe technical schematics that aren't strictly data visualizations. What's the multimodal advantage there?
For standard visual inputs like those, the output is often more about analysis and transformation. It can, of course, describe the image accurately. That's kind of the baseline now.
Table stakes, yeah.
But the crucial professional application often is transformation. Imagine a specialist, maybe an engineer or a field technician. They could photograph a complex piece of equipment, a specific machine part that failed, for instance. They could upload that photo and ask the AI to generate a detailed, step-by-step, textual maintenance or replacement manual based on its visual understanding of that part, cross-referenced with its vast text knowledge base of typical engineering requirements or known issues for that type of component.
So picture becomes instruction manual.
Potentially, yes. Or maybe even more powerfully, if you feed it a technical diagram, maybe a process flow diagram, the AI could instantly generate alternative visual representations of that same process.
Like simplify it or show it in a different format.
Exactly. Or create a detailed textual explanation of the diagram suitable for, say, a non-technical stakeholder, adjusting the language complexity based on the target audience you specify in your prompt.
That's incredibly useful for communication.
Okay, moving on from sight. Let's talk about hearing and communication, audio inputs. Professional life is just saturated with meeting recordings, interviews, presentations.
Endless hours of audio.
Right. We know AI can transcribe audio pretty well now. But how does multimodality elevate the value proposition of analyzing all that sound? What's the step up? Yeah, simple transcription, as you say, it's becoming a commodity. The multimodal leap here involves combining that transcription with immediate high-level synthesis of intent and context.
Intent and context. How so?
When you input a voice recording, say, of a project meeting, the AI doesn't just transcribe the words and give you a summary of topics. Its output can capture the nuances that actually define professional interaction.
Okay, like what kind of nuances?
Well, for example, the AI might analyze the tone, the turn-taking, the specific language used to identify who the key decision makers seem to be in that conversation.
Interesting.
It could discern patterns of agreement or disagreement around certain proposals and, crucially, maybe distill the 4 key action items discussed and potentially even assign a preliminary confidence score to those actions based on the energy level or degree of consensus observed in the preceding discussion.
Wow. Okay, that's far beyond just a summary.
Far beyond. You move instantly from the raw data, the spoken words, to an immediate synthesis of the conversation's strategic output. Action items, sentiment, key players.
That eliminates the need for someone, usually the most junior person, to listen back for hours, take detailed minutes, and manually try to figure out what was actually decided or where the disagreements were.
Right. It's an acceleration of organizational memory and decision tracking.
Okay, now tackling what might be the biggest data challenge. Video. Video footage contains visual information, audio information, and crucially, temporal data things happening over time. That seems like a huge lift for AI.
Video is definitely the ultimate synthesis task for multimodal AI right now. It has to juggle all those streams. When you input long-form video, the output is really about intelligent extraction and creating a useful narrative summary.
Intelligent extraction, meaning it pulls out the important bits.
Yes, but it's more than just highlights. The AI is tasked with navigating that temporal data, the timeline. So let's say you upload a 2-hour corporate training webinar. The AI won't just summarize the key points covered overall. It could potentially index every time a distinct new topic was introduced.
Oh, creating chapters automatically.
Yeah, exactly. It could identify the speaker associated with each segment, and maybe even extract the specific visual diagrams or slides that were shown on screen during that exact moment when they were discussing, say, Q3 projections.
That would be amazing.
It effectively compresses hours of this dense, time-based data into a structured, searchable narrative. It gives you, the user, a concise digest that respects the continuity and the different modalities within the original content.
That's incredibly vital for knowledge professionals thinking about our listener, the learner, who needs quick synthesis of long-form media. They don't have time to scrub through hours of video looking for that one crucial comment or statistic.
No, instead they just ask the AI. Find and summarize the segment where Dr. Evans discusses the implications of the Phase 2 trial results and show me the key chart she used.
And it takes you right there with the summary and the visual.
That's the goal. Instant access to the relevant multimodal chunk.
Okay, and finally, you mentioned one other element earlier, code. We should briefly touch on that. For many technical professionals, this is key.
Yes, we absolutely must mention the unifying element for many professionals, .code. For technical roles, multimodal AI processes code right alongside text and visual data. This is critical because code is often the underlying source data for the charts and the documentation.
It's the foundation for a lot of the other stuff.
Exactly. So the AI can analyze the code itself, explain its function in plain text.
Code explanation, okay.
It could potentially generate diagrams, visuals like flowcharts or dependency graphs based purely on the code's structure.
Visualizing code automatically.
Yes.
Yeah.
And even integrate explanatory text, maybe generated from the code's logic, directly back into the code's documentation loop.
Ah, so it helps keep the documentation in sync with the actual code.
Right. This helps eliminate that classic silo between, say, the engineer who writes the code and the product manager or the technical writer who needs the plain language explanation or the up-to-date diagram. It ensures the technical backbone of a project is processed and understood right alongside all the human communication aspects surrounding it.
Okay, this is where it gets really interesting, I think. We're connecting these multisensory capabilities we've just described directly to tangible professional workflow benefits. The source material is pretty explicit here. It basically says multimodal mastery equals a career superpower.
It does use that strong language, and frankly, based on the potential, it's hard to argue. It's about eliminating these massive historical friction points between different data types that have just plagued knowledge workflows for decades. Things that took time, manual effort, and introduced errors.
Right. Before we dive into the specific sector examples, maybe we should quickly acknowledge the platforms that are actually enabling this integrated synthesis right now. The source mentioned a few key players.
Yeah, absolutely. The source names the current sort of heavy hitters in this space: OpenAI's GPT-4o, Google's Gemini models, and Anthropic's Claude 3 Opus.
Okay. 4o Gemini Opus.
Right. And while all of them deliver impressive multimodality, the research does cite some subtle differences, or at least areas where they initially seem to shine.
Such as?
Well, GPT-4o, for instance, got a lot of early attention for its really powerful, almost real-time vision analysis capabilities. You know, interpreting things live through a camera feed.
Right. The demos were impressive.
Gemini is often lauded for its deep foundational integration across Google's ecosystem, search, workspace, etc., and its speed.
Makes sense, leveraging their infrastructure.
And Claude Opus is frequently noted for its ability to handle absolutely massive context windows. We're talking hundreds of thousands of tokens, which is particularly useful when you're analyzing, say, huge code bases and all the associated documentation simultaneously.
So different strengths depending on the specific task, maybe.
Possibly. And these things evolve fast, of course, but understanding these nuances might help you choose the right tool for a specific job. However, the core capability we're discussing today, that seamless integration of text, image, audio, video, code, that's the key feature across the board. And that's what unlocks the professional benefits we're about to explore. #A sector-specific applications.
Okay, let's detail these applications then.
Right.
Across different knowledge professions, show how this integrated intelligence really accelerates complex tasks. Let's kick things off with legal professionals. That's a field just defined by massive volumes of text, but also complex, multi-format evidence.
Oh, for lawyers, the potential acceleration is truly revolutionary. Think about their daily reality. They are constantly juggling at least 3 major distinct data sources.
Okay.
You've got physical or digital evidence that could be scans of documents, photographs of a scene, videos, the visual component.
Right.
Then you have mountains of case filings, motions, precedents. That's the core text component.
Paper trail.
Exactly. And then you often have deposition testimony, witness interviews, frequently starting as audio, then transcribed, often imperfectly, into text.
Okay, visual text, audio to text. Got it.
The huge pain point has always been cross-referencing these effectively and quickly, finding the connections, the contradictions.
I can imagine. Hours and hours of paralegal work.
Precisely. Now, multimodal AI allows them to, say, scan in a batch of physical evidence photos and simultaneously have the AI summarize key points from lengthy, often poorly formatted deposition transcripts. That's already a time saver.
Sure.
But more powerfully, it enables sophisticated cross-modal analysis. A lawyer could ask the AI, cross-reference every mention of Warehouse 7 in this 500-page deposition transcript against any visual evidence photos submitted that show damage potentially linked to that location.
Wow. So connecting the words directly to the pictures.
Instantly, the system links the spoken or written testimony, Warehouse 7 damage observed, to the relevant visual data points in the photos. It could spot inconsistencies, maybe the timeline mentioned doesn't match the photo evidence, or, critically, it could validate a crucial piece of testimony by finding the exact corroborating visual evidence.
And it does this in seconds.
Seconds or minutes instead of potentially days of manual paralegal review, sifting through boxes of photos and pages of transcripts.
That completely shifts the lawyer's focus. From laborious sifting to high-level strategy based on instantly correlated evidence.
That's exactly the idea, freeing up human expertise for the tasks that require judgment.
Okay, next example. Let's think about teachers and educators. They often blend visual presentation materials, like slides, with their own deeply detailed, sometimes nuanced, but often fragmented personal teaching notes.
Yeah, that's a great case. Teachers can really leverage multimodality to handle pedagogical data more efficiently. They can feed the AI, say, their standard PowerPoint slides. That's the visual and structural outline of the lesson.
Right, the student-facing part.
But plus, they can also feed it their own, maybe somewhat disorganized, but incredibly valuable personal teaching notes. You know, the ones with the verbal cues they use, the quick references to recent research, the anecdotal examples they tell in class to make a point stick.
The stuff that makes the lesson come alive but isn't usually formalized.
Exactly. The AI synthesizes these two streams, the structured visual presentation and the unstructured but rich textual notes. And the output, polished, cohesive teaching material.
Like generating a handout.
Could be. It could generate a student handout that's perfectly aligned with the visual flow of the slides, but also integrates the necessary conceptual depth or the engaging examples from the teacher's personal notes. It does the integration and formatting.
That moves the teacher away from tedious administrative formatting tasks.
And towards actually customizing the lesson, thinking about student interaction, refining pedagogy, much higher value use of their time.
Makes sense. Okay, the business world, particularly something like market analysis. That often involves trying to integrate structured data, like sales charts, with really messy, unstructured human communication, customer feedback, social media chatter.
Oh, yeah. This is where multimodality really shines in solving that classic data silo problem that businesses constantly struggle with. Think about conducting comprehensive market analysis. You need to integrate, typically, visual charts showing sales trends, revenue projections, market share.
The quantitative stuff.
Right. Then you have maybe transcribed audio calls from customer feedback sessions or focus groups, capturing raw sentiment, detailed complaints, feature requests.
The qualitative stuff.
Exactly. And then you probably have vast amounts of competitive intelligence gleaned from scraping social media text data, news articles, press releases.
Okay, charts, call transcripts, web text, 3 different worlds.
Totally different worlds, traditionally analyzed by different teams using different tools. Now, with multimodal AI, a single analyst could potentially formulate a single complex query. Something like, synthesize the likely causes of the Q3 revenue dip clearly visible in this uploaded sales chart. Specifically, link this dip to common themes related to poor customer service or product complexity mentioned in the attached customer feedback called transcripts from that quarter. And finally, provide a brief overview of how key competitors seem to be addressing similar service issues based on their recent social media posts and press releases.
Wow. That's a complex ask.
It is, but the multimodal system is designed for exactly this. It cross-references the visual trend, the dip, correlates it with keywords and sentiment in the audio transcripts, customer service complaints, and contextualizes it against competitive actions described in text, social media.
So it provides a single, synthesized answer drawing from all three data types.
A comprehensive 360-degree synthesis that just a short while ago would have absolutely required maybe 3 different analysts, or one analyst spending days manually collating findings from 3 different software tools.
Huge efficiency gain and potential for deeper insights by seeing the connections. Okay, and one final sector you mentioned where this synthesis capability has really profound implications, particularly for speed and accuracy. Doctors and other medical professionals.
Yes, in medicine, the speed and accuracy of diagnosis and access to the latest information can literally be life or death. Multimodality offers significant potential here.
How does it apply?
Doctors can input complex visual data, think MRI scans, CT scans, X-rays, ultrasound images. The AI analyzes this visual evidence, identifies anomalies, measures structures.
Okay, medical image analysis. That exists already to some extent.
It does, but the real multimodal power comes from immediately cross-referencing this visual data analysis with vast amounts of relevant text-based resources.
Like what?
Like the specific patient's electronic health records, EHR, pulling their history and prior conditions, like the latest published medical research papers on the suspected condition, like established clinical practice guidelines.
So it's not just analyzing the scan in isolation, it's interpreting the scan in the context of the patient's history and the global medical knowledge base.
Precisely. This integrated workflow can dramatically accelerate the diagnostic cycle. The AI might analyze the visual structure of a tumor on a scan, instantly retrieve the 3 most recent relevant research papers discussing that specific morphology,
Right.
and then summarize the current best practice treatment protocols based on that confluence of visual evidence from the scan and textual evidence from the literature and guidelines.
Providing the doctor with an immediate, high-confidence diagnostic support summary.
Exactly. It's not replacing the doctor's judgment, but it's acting as an incredibly powerful, incredibly fast assistant that can synthesize visual and textual medical data at a scale and speed no human could match. #tag deep dive into the Aisha example, the story scene.
Okay, to really ground this power in a concrete professional scenario, the sources provide this detailed illustration, the story of Aisha, a medical researcher. I think this really helps show what the integrated workflow feels like for the user, not just abstractly what it does.
Yes, the Aisha scenario is powerful because it highlights the elimination of those friction points we talked about. Her task is inherently complex. She needs to analyze patient data, understand the potential diagnosis, research it, report on it, and present her findings.
A typical research cycle.
Right. And traditionally, that would involve multiple steps, multiple tools, maybe multiple handoffs between different systems or even different people. Lots of potential for delay and information loss.
Okay, so how does Aisha use multimodal AI? What's her workflow?
She initiates her workflow by uploading the core data point, a raw MRI scan image, a complex piece of visual spatial data.
Right?
And crucially, the source emphasizes that AI isn't just storing the image like a file in a folder. It immediately begins structural analysis of the image content.
So it starts looking at the scan right away.
Yeah.
And she doesn't have to manually point things out or label the pathology for the AI first.
Apparently not in this idealized scenario. The system reads the complex visual structure autonomously, using its trained understanding of medical imaging.
Okay, what happens next?
The AI explains the visual structure it sees in the image analyzing findings, like tissue density variations, anomaly location and size, comparing it perhaps to normative data. It provides an initial visual breakdown.
So image analysis first.
Yes. But then the system transitions instantly seamlessly into textual synthesis. Based on its analysis of the image, it generates a comprehensive written diagnostic hypothesis.
Okay.
And importantly, it does this by cross-referencing its image analysis with its internal knowledge base, established medical literature, databases of similar cases it was trained on. This is that direct link. Visual input leading straight to structured, evidence-based textual synthesis.
Image to analysis to written report. All connected.
All connected. But the workflow in this example continues even further. Aisha then directs the AI, using that synthesized diagnosis and the cross-reference background material, to create a presentation deck summarizing the findings for her research team meeting.
So it generates slides.
It generates the slides. This is the final step described: transformation and output. The AI takes the initial visual data, the analytical text it generated, the supporting evidence it found, and transforms it all into a structured, professional presentation format, ready for immediate dissemination or refinement by OSHA.
That's the full cycle. From raw image input to analysis to report generation to presentation output, all managed within one integrated process flow, initiated from that single visual input.
Exactly. It truly starts to feel, as the source suggests, like working with a highly skilled, multisensory colleague, someone who can read the scan, write the report, and prepare the presentation slides, all as part of completing a single, coherent task.
Simultaneously, almost, without the usual stop-start between different tools or different phases.
Right. And the seamlessness leads to the undeniable impact that makes multimodal mastery feel like a superpower. The sheer scale of the efficiency gain.
This is the part that really stood out.
Aisha uses this integrated multimodal AI to analyze patient images, summarize the related research papers, create the presentations, all woven into this cohesive, uninterrupted flow. And the source material emphasizes the truly astonishing result.
Yeah.
She delivers in one day
One day.
what used to take an entire research team weeks to accomplish.
Weeks down to a day. That's transformative, not incremental.
Absolutely transformative. And that time compression happens precisely because the AI eliminates all those previously unavoidable delays. The minutes, the hours, sometimes days spent manually transferring context.
Like copying data from the scan report into the summary document.
Or manually searching PubMed to find papers that validate a visual finding from the scan.
Or formatting the findings into slides.
All those bottlenecks between the different senses, between the different representations of information, visual, textual, structural, it just dissolve. It turns what were week-long, multi-step administrative and analytical processes into something closer to a 24-hour sprint focused on results. Now, if we connect this level of cross-sensory synthesis, this Asha example, to the bigger picture trends, we're clearly moving beyond just thinking about these as powerful tools. We're entering a new phase, what the sources call the agentic future.
The agentic future, okay.
The sources strongly point toward the development and deployment of multimodal agents.
We've used the term colleague a few times already to describe how these AI capabilities feel. But let's clarify for the listener. What specifically differentiates a powerful multimodal tool, which is arguably what Aisha was using, albeit very effectively,
Right. She was directing it at each step.
from what the sources describe as a future multimodal agent? What's the key difference?
It's a great distinction to make. A multimodal tool, however powerful, generally responds to a specific, often one-off, cross-sensory command from the human user. Analyze this image and summarize it. Take this text and these slides and create a handout. You initiate, it executes.
Okay, command and response.
A multimodal agent, on the other hand, is conceptualized differently. It's designed to interact more like that human colleague we keep mentioning. It's given a broader goal or responsibility, and it can take initiative, plan, and manage complex, multi-stage tasks involving multiple sensory inputs autonomously over time.
Autonomously. All right, can you give an example of what that might look like?
Imagine an agent deployed to monitor, say, a complex engineering project or a manufacturing line. It might be programmed with the overall goal of ensure optimal performance and flag potential risks.
Okay, a general directive.
Right. Now, let's say the agent is monitoring a steady stream of performance data, perhaps presented on a visual dashboard that's visual data input. If the agent observes a significant performance anomaly developing on that dashboard,
It sees a problem starting.
it doesn't just wait for a human to notice and ask it to investigate. An agent might be designed to automatically take the next steps.
Like what?
It could automatically cross-reference that visual anomaly with the latest audio logs transcribed from the daily engineering stand-up meeting, looking for mentions of issues with that system, auditory text data.
Okay.
It might simultaneously analyze the code changes recently committed to the relevant software module, code data.
So it pulls data from multiple modalities on its own initiative.
Exactly. It then executes a chain of reasoning based on correlating these different data streams. It might draft a preliminary incident report explaining the likely root cause it identified. It might even generate an updated visual dashboard highlighting the specific risk area and projecting potential impacts.
And it does all of this triggered by that initial visual data point without needing constant step-by-step human intervention.
That's the core concept of an agent. Automated, proactive, comprehensive, cross-sensory task delegation towards a larger goal.
That shift from reactive query response to proactive management makes the speed gains we talked about with Aisha seem even more dramatic. The AI starts eliminating bottlenecks potentially before the human team even fully recognizes the bottleneck exists.
Precisely. It's about anticipating needs and acting on integrated data streams continuously. And this potential future state, this agentic future, makes our current takeaways for you, the listener, even more urgent.
Right, because the foundations are being built now.
Exactly. So for the professional who's keen on achieving genuine knowledge mastery in this evolving landscape, these 3 points really summarize the essential shift you need to internalize.
Okay, takeaway one.
Takeaway 1. AI is no longer just a text processing technology. It's fundamentally structurally multimodal. You really need to start thinking about how to integrate visual, audio, and maybe even video inputs into your standard professional analysis workflows right now. Don't treat them as separate add-ons.
Got it. AI, multimodal now. Takeaway 2.
Takeaway 2. This shift enables an almost exponential expansion of professional workflows. It moves beyond simple automation into high-level interaction and synthesis, allowing for those kinds of rapid, triangulated analyses that can compress weeks of fragmented effort into potentially a single day of focused work.
The Aisha effect. Weeks to days through integration. And the third takeaway.
Takeaway 3. Multimodal mastery truly is, without exaggeration, shaping up to be a critical career superpower. The ability to effectively manage, query, and synthesize knowledge across all the forms of human communication, text, image, sound, video, is rapidly becoming the baseline requirement for top-tier professional efficiency and maintaining a competitive advantage.
And critically, understanding this capability means recognizing that the time you previously spent doing that tedious manual matching a chart to a transcript, finding the right clip in a video, that time is now freed up. Freed up so you can dedicate your unique human skills to directing the AI on the next higher-level problem. The strategic questions, the ethical considerations, the creative, the problems that still require uniquely human judgment and deeper synthesis.
That's the new division of labor emerging. Humans move up the value chain to direction and judgment, while the AI handles the cross-modal synthesis and analysis at scale. Hashtag tag outro.
Well, this deep dive into multimodal AI has really shown us a capability that I think fundamentally changes our relationship with digital information. It's not just an upgrade, it feels like a different category.
It does feel like a step change.
We started by exploring that question. What happens when your AI can see your charts and hear your voice? And we've pretty clearly concluded that not only can it do that, but the immediate next frontier is working with it across every medium of communication as a single, integrated, and incredibly efficient intelligence.
The efficiency gains, as we saw, are just impossible to ignore, particularly when you look at that dramatic time compression highlighted in the medical research example, the Aisha story.
Yeah, the 1 day versus weeks.
That ability to deliver results so much faster because you're removing the friction between data types. It really shows how this integrated capability is rapidly moving from being maybe an academic novelty or a cool demo to becoming a standardized, expected professional tool.
Right. It's becoming table stakes.
I think so. And maybe I can leave you, our listener, with one final thought to mull over. Something that builds directly on that source material's projection of the agentic future we just discussed.
Okay, a provocative thought to end on.
If the AI agents of the near future are indeed handling the heavy lifting of synthesis, the cross-referencing, the rapid analysis across all these human senses, sight, sound, text, code.
If they become the ultimate data synthesizers.
Right. Then what new kind of highly specialized expertise will the human colleague, the human professional, need to develop? What's our new role? It seems it will be less about gathering and manually processing data across formats.
And more
about effectively managing, directing, and perhaps most importantly, critically assessing the outputs of this powerful, integrated, multisensory intelligence. How do you ask the right cross-modal questions? How do you validate the synthesized output? How do you steer the agent towards truly valuable insights?
So the human expertise shifts towards strategic direction and critical evaluation of AI synthesis.
Exactly. The future seems less about us doing the multisensory integration and more about skillfully directing the ultimate tool that does it for us and developing that directorial skill, that critical oversight, that I think is the challenge and the opportunity that defines the next decade of professional growth.